Hello and welcome! In this explainer, we're diving into a piece of technology most of us use every single day, the microwave oven. My name is Neelam Talreja, founder of Mindseed Tutorials right here in Malad, West Mumbai. I absolutely love helping students learn faster and smarter, and today we're going to pull back the curtain on the everyday magic of the microwave.
I mean, really think about it. It feels a little bit like science fiction, right? You put your leftovers in a box, you push a button, and a minute later, it's steaming hot. There's no fire, no glowing red coils. So what is actually happening in there? Well, let's demystify this little kitchen miracle.
So, you'd probably guess that an invention this revolutionary came from years and years of intense research into new ways of cooking. But you'd be wrong. The truth is, the microwave oven was a total accident, and it all started with a snack.
Let's hop in a time machine back to the 1940s. We've got an engineer, Percy Spencer, and he's working with something called a magnetron. Now that's basically just a high-powered tube that generates microwaves for radar systems. One day in 1945, while he's testing this thing, he reaches into his pocket and notices something odd.
And there it is. That's the aha moment. The candy bar in his pocket had turned into a gooey mess. It wasn't some grand experiment. It was just a simple, sticky observation. But that observation sparked a genius idea. If these invisible waves can melt a candy bar through my pocket, what else can they do? Could they cook food?
So how exactly do we get from a melted chocolate bar to reheating last night's dinner? Well, the secret isn't some special property of the food itself. It's actually all about something most of our food is full of: water. Let's get into the physics.
The star of this whole show is the water molecule. Now, water is what scientists call a polar molecule. That's just a fancy way of saying it has a positive end and a negative end, kind of like a teeny tiny magnet. And because pretty much everything we eat has water in it, these little molecules are the perfect target.
Okay, so here's how it all works. The microwave oven creates an electric field inside that flips back and forth, billions of times per second. All those tiny water magnets in your food try to align with this field, so they start spinning and tumbling like crazy to keep up. This super fast molecular dance party creates a ton of friction between the molecules. And what does friction create? Heat. That's it. That's how your food gets hot.
All right, so we have these powerful waves, and we have the water molecules ready to dance. But how do you keep all that energy focused on the food? You don't want microwaves just flying all over your kitchen, right? This is where the actual design of the box comes in, and it's absolutely crucial.
The solution is actually pretty simple. You build a metal box. See, metal surfaces are like mirrors for microwaves. They just bounce right off. So the inside of your microwave is basically a hall of mirrors, endlessly reflecting the waves and keeping them trapped inside, concentrated right on your meal.
Now all this bouncing around creates a really interesting effect. Instead of the waves traveling from one side to the other, they start to interfere with each other and create what's called a standing wave. Think of a guitar string. When you pluck it, it vibrates up and down in the same spot. That's exactly what's happening with the energy inside the oven.
And engineers are clever. They design the box to be the perfect size so that these reflections build on each other, making the standing waves even stronger. This whole setup turns the inside of the oven into what's called a resonance cavity. It's a space that's perfectly tuned to trap and amplify that microwave energy, making cooking super efficient.
But, as with many clever solutions, this one creates a brand new problem. You see, trapping the waves so perfectly isn't, well, actually perfect for cooking. Let's talk about why.
So, that standing wave pattern isn't uniform. There are peaks where there's a ton of energy, we call these hot spots, and there are valleys where there's practically no energy at all. Those are the cold spots. This means that if your food just sits still, some parts will get cooked, and other parts will stay completely cold.
And you can actually prove this yourself with a fun little experiment. Just take the rotating plate out of your microwave, spread some shredded cheese on a dish, and heat it for about 30 seconds. You'll see a clear pattern of melted puddles and totally unmelted cheese. You've just created a map of your oven's hot and cold spots.
Okay, so if the energy inside is so uneven, how in the world do we get our food to cook all the way through without some parts being frozen and others being burnt to a crisp?
The solution is so simple and brilliant, we don't even think about it. The turntable. That little rotating plate is a genius fix. By constantly moving the food around, it makes sure every part of your meal gets a trip through all the hot spots and the cold spots, averaging out the cooking energy for a perfectly even result.
All right, let's switch gears and tackle some of the big questions people always have about microwaves. Are they safe to use, and why do we use these specific waves and not some other kind?
First up, safety. The short answer is yes, they are completely safe. That metal box and the mesh on the door act as a shield called a Faraday cage, and it's designed to keep all those microwaves trapped inside. Now, why these waves? Well, it's a bit of a Goldilocks situation. Longer waves, like radio waves, would just pass right through the food. Shorter waves would only cook the very surface. Microwaves are just right. They penetrate the food perfectly to heat it quickly and efficiently.
So here's the bottom line. A microwave gets those water molecules jiggling all throughout your food, essentially cooking and steaming it from the inside out. That's what makes it so fast. A regular oven uses hot air to cook from the outside in. That's slower, but it's what gives you that delicious browning and crispy texture. They're just two different tools for two very different jobs.
And there you have it. The next time you press that 30 seconds button, you can think about Percy Spencer and his melted candy bar. It's just amazing that one of our most used kitchen gadgets wasn't planned at all. It really makes you wonder, doesn't it? What other magic is hiding in plain sight, just waiting for an accidental discovery?
Thank you so much for watching. If you want personalized guidance to help you understand the science behind our world, feel free to reach out to me, Neelam Talreja, at Mindseed Tutorials. All the details are right there on your screen. Thanks again.